Hello guys, welcome to our YouTube channel SME Dehradun. This is Bhupender Singh and you are watching our YouTube channel SME Dehradun. As you know, people are very busy in their life due to their hectic schedule. And due to this, they are forget to watering their plants. So today's tutorial is based on this project. How to monitor soil moisture level of your plant as well as automatic switch on the water pump while our plant needs it. All of these things you can monitor in your mobile app as well as you can also monitor in your web dashboard. You can monitor it worldwide anywhere. Many of the startup companies are working on IoT based plant monitoring system. So guys, to design this project you need the following components.
NodeMCU or ESP32 Wi-Fi board, a soil moisture sensor, a 12-volt water pump, 12-volt single channel relay, one 12-volt 2 ampere adapter or power supply, and few jumper wires. And this is the circuit diagram. You need to connect your hardware according to this circuit. You can download the circuit diagram from the video description. Now connect the hardware. This is a NodeMCU ESP8266 Wi-Fi board. You can use ESP32 board. You can download the programming code and circuit diagram for the ESP32 board from the below video description. This is soil moisture sensor that comes with its interface board. So we take two female jumper wires and connect the soil sensor to its interfacing board. It has 4 pins. First one is analog output pin, second is digital output pin, third is ground, and last is VCC. This is 12-volt single channel relay. It has 3 pins. First is 12-volt, second is ground, and last is input pin. This is base patch board for NodeMCU, designed by Nutty Engineer Company. It has external 5-volt, 12-volt and ground pins so that you can connect number of the sensors and output devices to NodeMCU. It is going to helpful in this project. So we place the NodeMCU in the base patch. This is 12-volt DC water pump. We will use it for the automatic pour water to the plant pot when sensor senses that plant required some water. I have a small pipe to connect it with water pump. So we take relay and connecting it to the NodeMCU board. Take 3 jumper wires and connect relays 12-volt to 12-volt, ground to ground, and input pin to D7 number pin of NodeMCU board. Now take soil sensor and connect it to the NodeMCU board. Take few jumper wires and connect VCC of soil sensor board to NodeMCU's 5-volt ground to ground and A0 means analog pin to A0 pin of NodeMCU. Now take water pump and connect it to the relay as per the circuit diagram. So we have connected all the hardware perfectly. And guys, verify all the connections once again before power up your hardware. So let's configure the Blynk web dashboard. Open the web browser and open the Blynk Cloud website by typing blynk.cloud. Here you can create your new account or login through your username and password. After login, you can see the Blynk dashboard. You can create your project template here. So click on the new template and template property gets opened. Here write your project name like soil moisture monitoring. Below select hardware as ESP8266 as we are working on NodeMCU and choose the connection type Wi-Fi. Add the description, write your project description and click on done. Once you have done it, you will see the info tab. Here firmware configuration. You will see the template ID and device name here. We have to write it in our Arduino program. Now in the metadata tab, we can see the information about our project that we have just created. In the data stream tab, we define the method of accessing the NodeMCU board pins like through virtual pin, analog pins or digital pins. So we choose the virtual pins. Click on the new data stream and choose virtual pin. Virtual pin property gets opened. Write the name as soil level, virtual pin as V0 and data type as double. Change max value to 100 as maximum soil moisture level is 100%. Now click on create. Now we create LED indicator for water pump. So click on the new data stream, then virtual pin. In the property, write the name as water pump. Select the pin as V1, data type as integer and click on create. Now we take another virtual pin for virtual LCD. Click on the data stream tab and click on virtual pin. Write the name as LCD. virtual pin as V2, data type as string, and click on create. So this is how we create our virtual pins. In the events tab, where you can create any notification for your events. Now go to the web dashboard. Here we drag and drop the widgets for our virtual pins. So we drag and drop label in the dashboard. Hover the mouse cursor on the label and you will see the setting icon on the switch. Click on it. Property gets opened. Select the data stream as soil level V0 and click on the save button. Now drag and drop the LED widget to the dashboard. Open the property. Select the data stream as water pump V1 and click on save. Now drag and drop the gauge widget to the dashboard and open the property. Select the data stream as soil level V0 and click on the save button. We have created the required widget in the web dashboard. Now click on the mobile dashboard, from which you can get the link to download the Blynk IoT mobile app for your iOS and Android mobile. Now click on save button to save the changes in templates. Let's go for the programming code. So go to the video description and click on the link given to the download the program for soil level monitoring. And once downloading is done, you will get the WinRAR file with the name soil with water pump NodeMCU. Right click on it and click on extract here. If you don't have WinRAR or WinZip software to unzip it, then a link is available in the video description to download these softwares. Once it's unzipped, you will get the folder with the same name. Go inside the folder and open the program. In the program, you can see the template ID and device name. We need to change these blank credentials with your blank credentials. So go to your Blynk Cloud dashboard. In the info tab, you will see the firmware configuration. Copy these credentials and replace it here. And we also need to add a library of Blynk to our Arduino IDE. So again, go to the video description and download the Blynk library. Once downloaded, you will get the zip folder with the name Blynk library master.zip. Now right click on the folder and click on extract here. As you can see, we have got the folder with the same name. Copy this folder and go to the location where you install the Arduino software. Go inside it and you will get the folder with the name library. Go inside this folder and paste the library here. So back to the programming code. Here we define Blynk firmware version of NodeMCU. After it, Blynk serial to print the serial data so that when it's ready, it will display in the serial monitor. After it, we define that we are using NodeMCU board. We define BlynkEdgent header file in this line. Here we define the A0 pin to soil variable because we connect the soil sensor to the A0 pin of NodeMCU. And similarly, we define D7 to water pump variable to operate the water pump. We also take widget LED with name pump to V1 virtual pin so that while it will indicate the power pump on off status to Blynk. Here we take two float variable as soil level to display the level of moisture in the soil and soil R to store the raw data of the soil sensor. And here you will get the new widget to know about. That is widget LCD. Means we also display the text in the virtual LCD in Blynk mobile app. Means the status of the water pump we will display in the virtual LCD also, but it is available only the Blynk mobile app. It is not available in the web dashboard. So we define the VLCD to V2 virtual pin. Now we create a separate function for water pump. Here we call the read soil function that we defined below. We get the soil level from this function. When soil level will be greater than or equal to 80, means when soil of our plant will be get 80% wet, then we switch off the water pump by giving the digital write command. Also, we write the text as water pump off to the virtual LCD and switch off the virtual LED by giving the pump.off command. And if the soil level will be less than 20, means moisture level in the soil will be very low, then we switch on the water pump by digital write command and display the text in the virtual LCD as water pump on and switch on the virtual LED by pump.on command. And here we make the function read soil that we call here. In this function, we take soil R as integer type variable and read the analog value from the soil using A0 analog pin by analog read command. We also serially print the soil's moisture level so that when internet is not available, then you can see the soil level in the serial monitor of Arduino or any other terminal. Here we measure the soil moisture level in the soil level variable using map function. Here we take soil raw data that we got from the sensor always between 0 to 124 and convert it to between 200 to 0 so that we can calculate the actual value of the moisture level of the soil. We serially print the soil moisture level and we send that data to the V1 virtual pin by using blynk.virtual write command. Now come to the setup. We serially begin the NodeMCU at 9600 baud rate. As our water pump is output device, so we define it as an output by pin mode command. And we off the water pump at the starting so that once our device goes up, then our algorithm will take the decision itself. Now we begin the BlynkEdgent function so that it can connect NodeMCU board to the Blynk server. After the delay of 2 seconds, we define the timer.setInterval function that will call the send sensor function every 1000 milliseconds, means in 1 second, so that send sensor function will update the value to the Blynk dashboard. Now in the loop function, we call the BlynkEdgent.run function to handle all the query sent by the Blynk dashboard. And in the timer.run function, it will regularly trigger the timer.setInterval function. So our programming code has been finished. Time to upload the program to NodeMCU. Connect the NodeMCU to the computer's USB port. Now select the Wi-Fi board. You need to go to the tools and click on the board and scroll below and select the NodeMCU 1.0 ESP32 module. If you don't know how to install the NodeMCU Wi-Fi board to the Arduino IDE, then a link is available in the video description that will show you how you can install NodeMCU or any ESP8266 board to Arduino IDE. After selecting the board, you need to select the COM port. So go to the port and select the port as COM8. After it, click on the upload button. The program has been uploaded. So now download the Blynk mobile app. Go to the App Store and search for Blynk, and Android users, they can download it from the Android store. This is old Blynk legacy app. Scroll below and this is Blynk IoT new. You need to install this app. Once downloaded, open the Blynk app. Here we got the two options, sign up or login. As we already created an account with Blynk, so log into it. Dashboard has been opened. Click on add new device. Here we got three options, connect to Wi-Fi, scan QR code and quick start device. Click on connect to Wi-Fi option. In the next screen, we got the ready button. This time provide power to your NodeMCU board. You can also connect NodeMCU to your computer's USB port for it. And click on ready. Here you will get the pop-up that start with Blynk. Click here to join. If you don't find any Blynk pop-up here, you can see my old videos. I have shows the way how you can get it. Okay. Here it asks us to connect it to the Wi-Fi. So select your Wi-Fi and write the Wi-Fi credentials and click on continue. Wait for 5 to 10 seconds to configure. You do not need to do it every time. Once it connected to your Wi-Fi, then it store Wi-Fi credentials to EEPROM of the NodeMCU. Once the profile is created, then click on continue, then done. Now exit from the app back to the main dashboard of the Blynk. Now we add the widgets to the dashboard. So click on your template and click on the setting icon. Inside it, click on the plus icon. Widgets has appeared. Scroll below and click on the value display button. It's added to the dashboard. Now we add LED. Also add gauze. And at last, we add LCD to the dashboard. We arrange them accordingly. Now we click on the value display button. In the property, we align the title to the center and font size to the large. Now click on the select data stream tab and select the soil level V0. Now back to the dashboard. Click on the gauze. In the property, we align the title to the center and font size to the large. Now click on the select data stream tab and select the soil level V0. Now back to the dashboard. Click on the LED widget. In the property, we click on the select data stream tab and select the water pump V1. We change the color of LED to red color and back to the dashboard. Now click on the LCD widget. In the property, we switch the button to the advanced. Select the data stream as LCD V2 and back to the dashboard. So guys, this is how our dashboard looks like. Now time for the live demo of this project. So we put the soil sensor to our plant pot and we put this 12-volt water pump to the water box and pipe to the plant pot, so that when water pump will start, water will pour to the pot. Now we connect the 12-volt 2 ampere power adapter to our board. Our board has been powered up. As you can see in the mobile app, the moisture level of the soil is 1% and LED indicator is on. It is also displayed in LCD that water pump is on. You can also see the water that coming from the pipe in the pot. Once I push soil sensor too deep in the wet soil, it detects the 100% moisture level in the soil and water pump has been triggered off. You can also see the status in the app. Again, I pulled up the soil sensor from the wet soil. It detects the low level of soil moisture and the water pump has been switched on again. I have taken another pot with some dry soils. When I put the sensor to dry soil, water pump has been switched on and you can see the water coming from the pipe. Now I put the sensor to wet pot, pump trigger to switch off. So guys, this is how you can also monitor your plant status anywhere in the world through Blynk 2.0 mobile app. If anyone wants this kind of solution, they can contact us. We provide such kind of solution to individuals as well as to startup companies. If you have any query or suggestion, write it in the comment box below. Please like, share and subscribe to our channel and videos. And don't forget to click on bell icon to get the latest update of our videos. All the material related to this video available in the video description. You can download it from there. All the programming codes are well tested and are in working state. Thanks for watching.